Rationalizing radical denominators. Let's say that we have something like 1 over the square root of 5. And the square root of 5 is an irrational number. So it becomes really difficult for us to see what this number is, because we have 1 divided by an irrational number. So we want to get rid of the radical in the denominator. And how can we do that? Well, let's say that I multiply the square root of 5 by the square root of 5. What I'm going to get is the square root of 25, which is just 5. So if I do this, I'll get rid of the radical down below in the denominator. So that is the process of rationalizing. But how can I just multiply the bottom of the fraction? How can I multiply it by the square root of 5 without making a change? Well, if I multiply the numerator by the square root of 5, nothing's going to actually change, because the root of 5 over root of 5 is just 1. And if I multiply anything by 1, I just get the same thing. How amazing, right? So 1 times the square root of 5 is just the square root of 5. So we have the square root of 5 over 5, which is equivalent to 1 over the square root of 5. And that is completely rationalized, or the denominator was rationalized. Now let me just give you a couple of different examples. Let's say I have something like 2 over 3 root 6. The square root of 6 is also irrational, so I want to rationalize this denominator. So I can just take the square root of 6 and multiply it down at the bottom, up top as well, so I don't change anything. And that way I'll get rid of the radicals. Why is that? Because I have 3 square root of 6 times square root of 6, and that's just 3 times the square root of 36. And over here up top we have 2 times the square root of 6, and down below we have 3 times, now root of 36 is, lo and behold, just 6, because 6 times 6 is 36, of course. And up top we just have 2 times the square root of 6, so we get 2 root 6 over 18, because 3 times 6 is 18. Then in this case we can actually divide top and bottom by 2 to simplify things a little bit more, and we end up with the square root of 6 over 9, which is perfectly equivalent to 2 over 3 times the square root of 6. Fantastic. But that's not it. Let me give you one more example so that you can scroll down, try some questions, click on the questions to try some, rather to watch some videos. Hopefully I'm making good sense today. I think I am. What if I have something like 1 over 1 plus the square root of 3? This is sort of a special case. If we have 2 elements down below, I'm going to have to multiply 1 plus the square root of 3 by its conjugate. What is the conjugate of 1 plus the square root of 3? This will be simple. All we need to do is take this, but switch the middle signal. So we have a plus here, let's make that a minus. For now, this may not make a lot of sense if you haven't seen this before, but just trust me, it will work, and we're gonna get rid of the radical down over here. So up top we have 1 times 1 minus the square root of 3, which is just 1 minus the square root of 3. And down below we just have 1 plus root 3 times 1 minus root 3. Okay. I promise that it will all make sense in a second. Now over here, down at the bottom, we're going to need to FOIL to expand this. and simplify. 1 times 1 is 1. 1 times minus root 3 is minus root 3. Plus root 3 times 1 is just root 3. And plus root 3 times minus root 3 is minus root of 9. Fantastic. Now look at this. Minus root 3 plus root 3, they cancel out. Wonderful. That's why we chose to multiply by the conjugate. And of course, we multiply the top by the same, otherwise we would be changing the fraction, and we don't want to do that. So over here we have 1 minus root 3 all over 1 minus the square root of 9 is just 3. So I can simplify this into 1 minus root 3 all over 1 minus 3, which is just negative 2. Okay, so, and look at this. There's no radical, there's no irrational radical down at the bottom anymore, down in the denominator. I guess we can simplify this a little bit further. I'll just simplify it over here because I ran out of room, like always, down below. And I'll multiply top and bottom by negative 1 just to make the denominator positive. So negative 1 times 1, negative 1. Negative 1 times minus root 3 is plus root 3 all over negative 1 times negative 2, 2. And that's now fully simplified. Wow, this was a long introduction video. Hopefully not a lot of people have fallen asleep. So again, just scroll down, try some questions because practice makes perfect. Try some of these. Hopefully they'll make sense. If not, click on the questions to watch videos. Good luck!